Hi folks, we're going to take a look at number 10 on page 386. So they give us these two vectors, each of which has an unknown. And they want us to find these unknowns that are going to make A and B collinear. In other words, A and B are going to be parallel to each other. And in the second case, where A and B need to be perpendicular to each other, and they ask us if these values are unique. Okay, so let's start with the first one. So two vectors are collinear if they can be drawn along the same line. In other words, if the vectors are parallel to each other. Okay, so what we need to determine is some k value, okay, such that k times 2p8 is equal to the other vector b, q412. Okay, so this is what it means for two vectors to be parallel, that they're scalar multiples of each other. Okay, as long as k is not equal to 0. So let's see what happens when we try to solve this. Okay, so if I multiply this in, I know that the x component here, which would be 2k, needs to be the x component on that vector. So it needs to be equal to q. Okay, we need the y component, which would be p times k, needs to be equal to the y component here, 4. Okay, and lastly the z component, so 8k, needs to be equal to the z component here, so 12. Okay, now I notice here this last one, there's only one possible answer. I mean, there's lots of possible answers for these other two equations, but for this one here, there's only one possible answer. Okay, that k is equal to 12 over 8, which is the same as 3 over 2. Okay, so this gives me the idea that there might actually be just unique solutions here. So if k has to be equal to 3 over 2 in order for the z components to work out, let's now replace that in the previous ones. Okay, so if I have p times 3 over 2, that needs to be equal to 4. So p is just equal to 2 times 4 is 8. Divide the 3, 8 over 3. Okay, and here 2 times k, which is 2 times 3 over 2, needs to be equal to the q value, and so q needs to be equal to 3. Okay, so here we see that the values are unique. Okay, there's only one value of p and one value of q that are going to work to make these vectors collinear. Okay, and the reason being is that the z components, they were fixed, 8 and 12. So there's only one scalar multiple that'll take 8 to 12, namely 3 over 2. Okay, so let's look at the second one here. So second one, we need these two vectors to be perpendicular. And you have to remember that big characteristic we have about perpendicular vectors now is that their dot product has to be equal to 0. So if A and B, in order for A and B to be perpendicular, I need the dot product to be equal to 0. So that means we need 2p8 dot q412 to be equal to 0. And so we'll just find the dot product of the left side. So here we have 2q, okay, plus 4p plus 8 times 12 is 96, equal to 0. And I notice here that what I end up with is an equation with both p and q. Okay, and we can see that there's going to be infinitely many solutions here. So let's simplify it. First I'll divide everything by 2. So we have q plus 2p plus 48 equal to 0. So here we have infinitely many solutions. Okay, and in particular, if we want 1, well, let's take something easy. Let's let p equal to 0. Then q is just going to be equal to, I'll just bring the 48 to the other side, negative 48. Okay, but there's many, many other solutions. Okay, so just to recap, we needed to use two facts. The fact that if two vectors are parallel, then it means they're scalar multiples of each other. So we use that fact to solve the first one, and we use the fact that two vectors that are perpendicular need to have a dot product equal to 0, and that's what we use to solve the second part. Okay, that's it for this one.